Hello and welcome to another section of this complete Angular course. As you already know that Angular has introduced a new feature in Angular version 16 called as signals. So in this section, we will try to understand what is a signal, what is its use, and why you might consider using signals in your Angular application. We will also learn how to create and use a signal in an Angular application. And we will also learn about some important APIs which signals provide. Now, in this lecture, let's try to understand what is a signal and what is the reason Angular has introduced signals. So at the moment, by the time I'm recording this video, signals have been introduced only as a developer preview. This feature is likely to be stable once Angular version 17 is released, but at the moment, it's just a developer preview. And that simply means that both the syntax and the feature set around signals is likely to change. And it is also already clear that most signal related features will be added in the future versions of Angular. And also, patterns and best practices around signals are still to evolve. So in this section of this complete Angular course, I will help you get started with signals and cover some of the basic concepts around signals which is already available in Angular version 16. And in this lecture, let's learn what signals are and why do we might want to use them. And from the next lecture, we will start creating and using signals in our Angular application. So by definition, a signal is a wrapper around a value that can notify interested consumers when the value changes. And signal can contain any value. It can contain simple primitive values, or it can also contain complex data structures like arrays or objects. Now don't worry if this definition does not make any sense right now. You will understand this when we will start creating and using signals in our Angular application. But before that, let's try to understand why Angular introduced this signal feature. Without signals, Angular application relies on change detection cycle to find out if some data has changed, and then it updates the UI based on that change. Let's try to understand this with an example. So here I have created a brand new Angular project called Angular Signals. In this project, if I expand this source folder and if I expand this app folder, there we have this app component. If I go to the HTML file of this app component, here we have a very simple HTML, and in here we are using another component called signals, and I have created this component here. And if I expand this signals component, and if we go to the HTML file of this signals component, there also we have a very simple HTML. Basically, we have two buttons, this minus button and this plus button, and in between we are displaying the value of a counter property. So if I go to signal component.ts file, there in this file we have two properties. We have this counter property and we have this message property. So in the view here we are displaying the value of the counter property. Then we are also binding this click event on this minus button and on this plus button. So when this minus button is clicked, we are calling this decrement function. If I go back again, here you will notice we have this decrement function, and in this function all we are doing is we are decrementing the counter value by 1. In the same way, we are also binding this click event on this plus button. And there, when the click event happens, we are calling this increment function. And in the increment function, again, we are simply incrementing the value of counter by 1. Then we also have another div, and inside this div, what we are doing is we are using this ng-for directive to loop over this message array. So in the component class, we have this message property, which is storing an array. Currently, this array is empty. And in this component class, we are not doing anything with this message array. But basically in the view template, what we are trying to do is we are trying to loop over the elements of message array and we are displaying its value. Currently, it is not going to display anything in the view because this message array is empty. So if I go to the web page, here you will notice that we have a very simple Angular application where we have two buttons, minus and plus. And when I click on this plus button, it is going to increment the value of counter property. And when I click on this minus button, it is going to decrement the value of counter property. Now the question here is how Angular is updating this value when we are clicking on this plus button or this minus button. The answer is it uses change detection cycle. So what happens is whenever the value of a property in the Angular application changes, Angular runs a change detection cycle. And using change detection cycle, it identifies if a data has changed or not. If the data has changed, it will update the UI with the updated value. Now, when Angular will run this change detection cycle? Well, on this minus button and on this plus button, we have binded click event. So whenever one of these buttons will be clicked, Angular will run a change detection cycle to check if the value of a property has changed or not. In this case, it will run the change detection cycle to check if the value of this counter property has changed or not. If the value has changed, it will update this counter value and it will also render the updated value in the UI. And to show you that Angular is running a change detection cycle whenever these buttons are clicked, what I will do is, in the component class, I am going to add ng-doCheck lifecycle hook. Now we know that this ng-doCheck lifecycle hook gets called whenever a change detection cycle runs. And in order to use this ng-doCheck lifecycle hook, I'm also going to implement doCheck interface for this component class. And to use this doCheck interface, we also need to import it from angular/co. And inside this, I'm simply going to write a console.log statement. And in that console.log statement, I'll simply say Angular change detection called. Okay, let me save the changes here. And let's go back to the web page. Let's open developer console here. Let me clear everything. And now just notice what happens when I click on this plus button. You will notice that that message Angular change detection cycle called that has been logged here. If I click on this minus button, again that message has been logged here. Again, if I click on this minus button, again that message has been logged here. So every time we click on one of these two buttons, it is going to call the change detection cycle in order to check if something has changed in the Angular application or not. And if something has changed, Angular will update the UI with that change. And this is the behavior we want for our Angular application, right? We want Angular to update the UI whenever some data changes in the Angular application. So this is the expected behavior. But the problem here is that if this button is clicked, but if it does not change the value, if it does not change any data, then also the change detection cycle will run. Because in that case, since an event has happened and we are binding that event in the HTML file here. So here we are binding this click event on these two buttons. So whenever these two buttons will be clicked, Angular has to check for that click event if something has changed in the Angular app, if some property or some data has changed or not. So even though if no property or no data is changing, Angular will run the change detection cycle. So if I go back to VS Code, and let's say when this minus button is clicked, instead of calling this decrement method, I will simply pass 0 here. That means when this click event will happen, we are not doing anything. We are not decrementing the value of counter property. But still, if I go back to the web page, let me clear the console again. And when I click on this minus button, you will notice that the counter value has not changed. But still, the change detection cycle has run. If I click on it again, again the change detection cycle has run, even though no data has changed in the Angular application. And this is a disadvantage. So when we rely on change detection cycle to update the UI whenever the data changes, it works as expected. But the problem is change detection cycle also gets called when no data has changed. So this change detection cycle gets called very frequently. And this can impact the performance of our Angular application. Another thing which you need to remember is that behind the scenes, the change detection cycle algorithm uses a library called as zone.js. And since we need this zone.js file for running change detection cycle, when we run our Angular application and when the bundles are downloaded, those bundles also contains the zone.js code. For example, here if I go to network tab, let me move this console window a little bit up. Let me clear everything. And let me reload this page. So when we run an Angular application for the first time, it download all the bundles and files which is required for that Angular application. So you can see it has downloaded the runtime.js, polyfills.js, vendor.js, main.js and style.js. So these bundles contains our CSS styles, the JavaScript code which we write for our Angular application. It contains the HTML markups, and it also contains the JavaScript code of the other Angular modules which we are using in our Angular application. And these bundles also contains the JavaScript code of third-party libraries which we are using in the Angular application. And Joan.js is one such external library which we use in our Angular application, because Angular depends on Joan.js library in order to run change detection cycles. Now, the disadvantage here is that since our Angular application depends on Joan.js library, it increases the bundle size of our Angular application. So this is another disadvantage when we rely on change detection cycle for updating the UI whenever something changes in the Angular application. And finally, Joan.js library also does not tell Angular which component has changed and which part of that component has changed. So let's say in our Angular application we have 15 components. And out of those 15 components, in one of the component, a property of that component has changed. But Joan.js library cannot tell Angular in which component and which property has changed. So what basically happens is, whenever something changes in our Angular application, even though that change has happened only in one component, Angular will have to re-render all the components in the component tree, because Angular does not know where the change has happened. And that's because Joan.js does not tell Angular in which component or in which part of the Angular application the change has happened. So this is another disadvantage. And all these disadvantages which comes with change detection mechanism, it can affect the performance of our Angular application. And to overcome all these problems, Angular has introduced signals in Angular version 16. Signals gives us an alternate way of managing and detecting changes in the data and update the UI. In this way, it allows Angular to get rid of that extra Joan.js library. That's because with signals, we do not have to rely on change detection cycle to detect the changes and update the UI. And since we do not have to rely on change detection, we don't need that library at all. Also, with signals, we do not have automatic change detection. Instead, we as a developer tell Angular when the data changes, and we as a developer tell Angular where the data is used. And therefore, Angular knows which part of the UI needs to be updated with what data, and only those parts of the UI gets updated. So unlike with change detection cycle, where a single change leads to complete re-render of the component tree, using signals, we can tell Angular in which component the change has happened and which part of the UI needs to be updated. So when working with Signal, we as a developer will have to do slightly more work, but as an upside, we will have full control and we can very likely achieve a better performance for our Angular application. And in this way, Signals leads to a better performance and a smaller bundle. And that's why Signals are added in Angular and why we should consider using them. So I hope now you have got a better idea of what we are going to use Signals for and why it has been introduced. In a very simple words, we can say that Signals will allow us to improve the performance of our Angular application significantly. Now keep in mind that Signals are still in developer preview. It is not completely stable yet. So these advantages which we have talked about Signals, it will only really be available once Signals are stable and only after you fully switch to Signals in your Angular application. As long as you have one component which relies on change detection approach, you will not get too much benefits from Signal. And at the moment with Angular 16, you can't fully switch to Signals yet. But in the future, once the signals are stable and can be fully utilized in Angular application, you will get those benefits. In the last lecture, we learned what is a signal and why Angular has introduced signal feature in Angular version 16. So using signals, we can tell Angular when to update the UI and where to update the UI. Now in this lecture, let's learn how we can create and use a signal. In order to use signals, you need minimum Angular version 16. So you cannot use signals in older versions of Angular. You need minimum Angular version 16 and later version in order to use signals. So if I go to package.json file, you will notice that here all the Angular libraries which we are using, it has version 16. So for this project, I'm using Angular version 16, so I should be able to use signals. But if you're using any previous version like Angular 15, 14, or any other previous version, then you will not be able to use signals. So this is very important to understand. We can only use signals in Angular version 16 and later versions. With that being said, let me go ahead and let me close this package.json file, and let's go ahead and let's create a signal. So let's go to signal component class. In there we have two properties, this counter property and this message property. Now currently these two properties are normal properties. So whenever the value of these two properties will change, Angular will have to run change detection cycle in order to update the UI with the updated value for these properties. But now what we are going to do is, we are going to change this counter property into a signal. And to do that, the first thing which we need to do is, we need to import signal from angular/co. Okay, so this is the first step. Now we are going to use this signal. So what we want is, we want to convert this counter property into a signal. For that, what we need to do is, we need to use signal keyword, and here we need to use this signal as a function. Basically, we need to call this signal function. Now keep in mind that this signal, it is going to return us an object. In that object, we will have some methods and properties, and we will talk about it later. So here in this way, we are creating a signal. Now here we have two errors. The first error we have here, and here we have this error because here we are creating a signal. So now this counter, it is going to store a signal. It is not going to store any number value now. So I need to remove this type from here. Okay, so that error is gone. Now here we have second error, and here it says it expects one or two arguments, but we have not specified any argument when we are calling this signal. So to this signal, we need to pass an initial value which we want to assign to this counter signal. And here to this counter signal, initially I want to assign 0. Okay. Now you will also see that we have these errors. So basically, now this counter, it is storing a signal value. So now we cannot update the value of this counter like this. We cannot use an arithmetic operator on a signal. And that's why we have this error. Because here we are using an arithmetic operator on this counter signal. So from here, I'll go ahead and I will remove this increment operator and also this decrement operator. And you will notice that that error is gone. All right, so here we are creating a signal. Now how we are creating the signal? By calling this signal function. And this here, it is going to return us an object. It is going to return us a signal object. And that object is basically a wrapper around this data. So now, whenever the data will change, whenever the value of this counter signal will change, it will notify Angular about that change. And in this way, Angular will know that a signal value has changed. So it has to render that updated signal value in the UI. Now, where are we using this counter? We are using it in the view template. So we are using it here. Now, currently, if I go to the web page, let me close this developer console here. You will notice that instead of showing the initial value of the counter signal, it says function. Now, why is that? That's because, as we learned, this signal, it is going to return us a function. So this counter here, it is storing a signal function. And when we are simply specifying this counter here, as we learned, it is storing a function. It is not storing any value. It is storing a function. That's why in the UI, we are seeing this strange output. Now, how to fix this? In order to fix this, all we have to do is, we simply have to call that signal function. And for that, we can use a set of parentheses like this. And in this way, when we are calling this signal function, this counter signal function, it is going to return us the updated value. So initially to this counter signal, we have assigned 0. So 0 will be returned. But in the future, whenever the value of this counter signal will change, that value will be returned when we are calling it like this. And it will be updated in the UI. So when we are calling this counter signal here, and when this function will be executed, Angular will recognize and it will memorize where this signal has been used. So we are using this signal here at this place in the UI within these spans, right? So Angular will memorize this place, and In future, whenever the value of this counter signal will change, Angular will come to this place and it will simply update the value here. It is not going to re-render the complete component. It is only going to re-render that part of the UI where the change has to be updated. And this is the big advantage with signals. So now if we go to the web page, now we should have the proper value. So initially we have assigned counter signal with the value 0. So that 0 is being displayed here. But currently this plus and minus button will not work because we have not written the logic. So now what we want is whenever this plus button is clicked, we want to increment the value of counter signal. And whenever this minus button is clicked, we want to decrement the value of counter signal. So we basically want to update the signal value. So in this lecture, we learned how to create a signal. So here we are creating a signal and how to use a signal. So here we are using a signal. In the next lecture, let's go ahead and let's learn how we can update the value of a signal. In the last lecture, we learned how we can create and use a signal. Now in this lecture, let's try to understand how we can update a signal value. For that, in Angular, we have three methods using which we can update a signal value: the set method, update method, and mutate method. In this lecture, we will learn how we can use set method and update method to update the value of a signal. And in the next lecture, we will talk about mutate method. So let's go to VS Code, and here we are creating a signal. Now, to this signal, for the initial value, we are passing a numeric value, 0. But keep in mind that here we can also pass a string value, for example, hello, or a Boolean value, maybe true, or we can also pass an array, or we can also pass an object. So any type of value we can pass to this signal as an initial value. Here we want to pass a numeric value 0 because we want to assign this counter signal with an initial value 0. Alright. Another thing which you need to remember is that this signal which we have created, it is called as writable signal because here we can update the value of the signal. Now let's see how we can update the value of a signal. So as we learned, we have three methods to update the value of a signal. We have set method, we have update method, and we have mutate method. So let's first learn how we can use set method to update the value of a signal. So what we want is when this increment button is clicked, when this plus button is clicked, we want to increment the value of this counter signal by 1. Let's see how we can achieve that. Let's go to signal component class, and in there we have this increment method. Inside that we are using this counter signal. But here we are simply specifying the counter signal. We are not doing anything with that. Right. So on this counter signal, we can call set method. As we learned, a signal is nothing but an object, and that object has this set method. Now to this set method, we need to pass the new value which we want to set for that signal. For example, here initial value of this counter signal is 0. I want to increment it to 1. Okay, so here we are passing a new value which we want to set for this counter signal. Now here it is not going to increment every time we click on the increment button. Here from 0 it will set its value to 1. So the new counter value will be 1. But again when we click on the plus button, the previous counter value is 1 and the new counter value which we are specifying, that is also 1. So after 0 it will change to 1 and it will always set to 1 whenever this increment function will be called. If I go to the web page, initial value is 0. When I click on this plus button, its value has changed to 1. And now, no matter how many times I click on this plus button, its value is not going to change because every time this button will be clicked, this increment method will be called, and there we are simply going to set its value to 1. Now here what we want is, we want to increment the value of the counter signal based on its previous value. Can we do that using set method? Yes. Let's see how we can do that. So this counter signal here, it is going to store the updated signal value, right? So we are going to access this counter signal here. For that we can say this dot counter because it is simply a property here. And in order to get the value of the counter signal, we need to call it because as we learned, it is a function. And to that, we can add 1. So now, every time this increment method will be called, this set method, it will first read the previous value of this counter signal, and to that previous value, it will add 1. So now if we save the changes, if we go to the web page, now every time this plus button is clicked, it should increment the value of the counter signal. So it is working as expected. Now here what we are doing is, we are using this set method to update the value of the counter signal based on its previous value. And for that, instead of using this set method, we should be using update method. Now, we should use this set method whenever we want to set a new value, and that new value does not depend on the previous value. We can of course use set method to update the value of a signal based on its previous value. Just now we have seen that. But in such scenarios where the new signal value depends on its previous value, we should be using update method instead of set method. And that's because the update method receives the previous signal value. So here, instead of using this set method, we are going to use update method because we want to update the counter signal value based on its previous value. So here we can say this dot counter, which is the signal name, and on that signal we are going to call update method. And to this update method we need to pass a callback function. Okay. Now this callback function here, it is going to receive the previous value of this counter signal. So Angular will pass the previous value of this counter signal to this callback function as its argument. Let's simply call it prev value. Okay, so for previous value. And now we have the previous value of the counter signal. All we want to do is we want to add 1 to it and we want to return that value. And this should also work. So if I save the changes, if we go back to the web page, and when I click on this plus button, you will notice that every time this plus button is clicked, the value is getting incremented. So here, since the new value of this counter signal depends on its previous value, we should be using update method because update method receives the previous value of the signal. So in this lecture, we learned about this set method and update method. In the next lecture, let's understand the use of mutate method and how we can use it to update a signal. In the last lecture, we learned about set method and update method in order to update a signal value. So we learned how we can use set method and update method to update a signal value. Now in this lecture, we are going to talk about another method called mutate, and this mutate method we also use for updating a signal value. So in this lecture, we will learn how we can use mutate method to update a signal value and what is the difference between mutate method and update method. So mutate method works just like update method. The only difference is that you can use mutate method only on mutable values. For example, value types like number, string, boolean, etc. are not mutable. Let's say we are creating a variable a and to that we are assigning a numeric value 10. So an identifier called a will be created and somewhere in the memory this value 10 will be stored and that identifier will point to that value 10. But later in the program, when we change the value of a, let's say to 20, in that case, this value 10 will not change to 20. Instead, somewhere in the memory, a new value called 20 will be created. And now this variable a will point to that value. So you see, the previous value is still there, but since it is not mutable, it cannot be changed. And since it cannot be changed, a new value gets created in the memory and the identifier then points to that new value. So just like numbers, string and boolean types, they are also not mutable. They are immutable. But arrays and objects, they are mutable type. Their value can be changed. For example, here we are creating an array and this array has 3 elements. So in the memory, an array will be created and this identifier is going to store a reference of that array. Now let's say later in the program we push a new element to that array. So here you notice that that array itself has changed. We have not created a new array with that extra new value. Instead, in that same array, that new value has been added. So array is of mutable type. It can be mutated. It can be changed. In the same way, objects are also mutable. We can change its property value. But value types like number, string, boolean, they are immutable. Their value cannot be changed. So we should use update method when we are working with immutable type, and we should use mutate method when we are working with mutable type like arrays and objects. Let's try to understand the difference. Let's go back to VS Code. So in the last lecture, we used this update method inside this increment method. And here we are using this update method to increment this counter signal value by 1. Now let's also go ahead and let's use the same logic inside the decrement method. So here I will replace this line with this statement. But here we want to update the value of this counter signal. And how do we want to update it? We want to decrement the current value of this counter signal by 1. So in the previous value, we will have the current value of the counter signal. To that, we will subtract 1. With this, if I save the changes, if I go to the web page, and here when I click on this plus button, the value is incrementing. And when I click on this minus button, still nothing is happening. That's because in one of the lectures, to this click event, we bind it 0. But here, we need to set it to decrement method. Okay. With this, let's save the changes. Let's go back to the web page. And now this minus button is also working. All right. Let's go back. So here we also have another property called message, and this message, it is storing an array. Now what we want is we want to change this message property to a signal. For that, here instead of assigning a value, instead of assigning an array, we need to call this signal function, and to this signal we need to pass an initial value for this message signal which we are creating. So here for the initial value to this message property, we want to assign an empty array. Now here we have an error because again this message property is now storing a signal. It is not storing a string array. So let's remove this type from here, and that error is gone. But if we want, we can explicitly specify that this message property is going to contain a string array. We can specify it here. So the signal is of generic type. So here we can use angle brackets, and inside that we can specify the type. So here the type is going to be string array. Okay. So now this message, it is a signal. Now what we want is, so since we have changed this message property to a signal, now here we need to use it like a signal. And we know that a signal is nothing but a function. So this message signal here, it is going to store a function. And in order to get the value from within that signal, we need to call that function like this. And now that error should be gone. So what we want is every time this plus button is clicked, we want to push a string value inside this array. And whenever this minus button is clicked, we want to remove the last element from that message array. So inside this increment method, let's say this dot, and let's try to access this message signal. And what we want to do is we want to update the message signal. And how do we want to update it? We want to add a new element to the string array which this message signal is storing. For that, on this message signal, we can use update method. Okay. Now to this update method, we need to pass a callback function, and this callback function, it is going to receive the previous value. So for the first time, it is going to receive an empty array because the initial value which we are assigning to this message signal, it is an empty array. So for the first time, it will receive an empty array. To that, if we add some element, then next time it is going to receive that new array with some elements. Okay, so here we are going to receive the previous array. I'll simply call it as prev message. You can name it anything. And inside this prev message parameter, we are going to receive the previous value of this message signal. And to that, we want to push a new element. So here I'll say prev message dot push. And to this, we are going to push a string value. But now you will notice that we have an error. Okay, so we know that this update method, we need to use it only on immutable type. Here, we are trying to use this update method on a mutable type. Now, what this update method does is, it does not change the existing value. Instead, it overrides that value. It creates a new value. Here, when we use update method, what it will do is, it will create a new array, and in that array, it will try to push the value which we are passing to this push method, which is not allowed by push method. And that's why we have this error. So we cannot use update method in this case. But if you still want to use update method, what you can do is, you're already getting the previous array. From that previous array, here we are going to use a set of square brackets. In there, we are going to use spread operator on this prev message. So this prev message, it is storing an array. What this spread operator will do is, it will extract all the elements from that previous array. And now those elements will become an element of this new array. And in that new array, we can also add the new value which we want to push. So for example, we'll say current value of counter is, and then we'll specify the counter value. For that, I'll say this dot counter, and we will call that signal. Okay. So what we are doing is, here, first we are extracting the elements from the previous array and we are making it an element of this new array. And then in that new array, we are also adding one more element. So this is going to work. If I save the changes, and if you go to the web page, and if I click on this plus button, you will notice that a new div element has been added with the value, current value of counter is 1. Okay, so every time we click on this plus button, it is adding a new div in the web page. So it is working as expected. But the problem here is that every time we are clicking on this plus button, every time it is creating a new array. In that new array, it is extracting the elements from the previous array, okay, and then it is adding the new element. But here we don't want this behavior. Okay, so here this approach is working, but it is not the proper approach. So here I'll comment this line, and instead of using update method, now we can use mutate method. So now I'll say this dot message. So it is a signal, and on that I'm going to call mutate method. And to this mutate method also we need to pass a callback function, and this callback function is going to receive the previous value of the signal. So again I'm going to call it as prev message. And now all we need to do is, we need to push the new element to this previous value, to this previous array. Now what do we want to push here? Let's simply copy the string value from here and I'll push it. Okay. So now if I save the changes, if I go back to the web page, the functionality should still be working, as you can see, but now we are not creating a new array every time this increment button is clicked. Instead, we are pushing a new element to the same existing array. Because array is a mutable type, we can mutate its value. And to mutate the value of a mutable type, we are using this mutate method. But this update method, it cannot mutate the value. It will override the value. Okay, so even though we are using this update method on a mutable type, it is not going to mutate its value. It is going to override its value, which we don't want. So this is the difference between update and mutate method. Let me go ahead and let me copy this line, and I'll also add it in the decrement method. But here we don't want to push anything, so I will remove this line from here. Instead, we want to remove the last element from the array. Okay, so every time the decrement button is clicked, we want to remove the last element from the array. And when we remove the last element from the array will be updated. And in that case, Angular will know that this message signal has changed, so it will also update the UI. If I save the changes again, if I go back to the web page, every time I click on this plus button, it is adding a new div, and every time I click on this minus button, it is removing that div. So I hope now you have got the difference between the update method and mutate method, and when should we use update method and when should we use mutate method. As we learned, the mutate method works just like update method. The only difference is that we can use mutate method only on mutable values. When we use update method, it overrides the existing value and create a new value. It does not change the existing value. And that is the difference between update and mutate method. We can of course use update method on a mutable type, but in that case also it is not going to update its value. It is not going to mutate its value. Instead, it is going to create a new value from the existing value. In the previous lectures, we learned how to create a signal, how to use a signal in a view, and also how to update a signal value. Now, to conclude this section, there are two other important features which already exists in Angular, and I wanted to cover them as well. And the first feature which I want to talk about is the computed function. And to use computed function, first we need to import it from angular/co. Okay. Now here, let me go ahead and let me create a new property. I'll call it double counter. And to this, I'm going to assign computed function. Now, what do we use this computed function for? We use computed function to compute a value from a signal. For example, first of all, to this computed function, we need to pass a callback function. And inside this callback function, we can write a logic to compute some value from a signal. So here, what I want is, I want to compute a new value from this counter signal. So first of all, I will access that counter signal. For that, I can say this dot counter, and since it is a signal, we need to call it like this. And to that, I want to multiply 2. And in this way, here we are computing a value from this signal. And this computed function, it is going to return a signal which will be assigned to this double counter property. And that signal is going to store this computed value. So remember that this double counter property, it is going to be updated every time the value of this counter property changes. Let's say the current counter value is 2. In that case, this double counter value will be 4. And now let's say the value of this counter has changed to 3. So as soon as the value of this counter signal will change, the value for this double counter will be re-evaluated. So its value will be re-evaluated based on the new value of this counter signal, and that value will be assigned to this double counter. Now let's go ahead and let's use this double counter signal in this view template. So here, instead of displaying the value of counter signal, now we are going to display the value of double counter. And since it is storing a signal, we need to call it. Okay. So again, remember that every time the value of this counter signal will change, based on that change, the value of this double counter will also get updated. And this is the use of this computed function. So if we save the changes, if we go back to the web page, so the current value is 0. When I click on this plus button, the current value will be 2 because the counter value is 1. So to that, 2 will be multiplied. So the double counter value will be 2. If I click on this plus button again, the counter value is 2. So the double counter value will be 4. If I click on this minus button, the new counter value is 1. So the double counter value is again 2. And here, when we are using this double counter signal, Angular will also memorize that double counter is being used here. And it will understand that double counter uses counter signal as an input. And that's why Angular will recompute the value of double counter whenever the counter signal value changes. And it will update the UI whenever the double counter value changes. So Angular watches for all these changes. And therefore, the computed function gives us a smart and easy way of computing values that depends on other signals. Another signal function which I want to cover here is the effect function. And again, in order to use the effect function, we first need to import it from angular/co. Now we use effect function whenever we want to execute some code when the value of a signal changes. So for example, let's say you want to execute some code whenever the value of this counter signal changes, or you want to execute some code whenever the value of this message signal changes. So you can do that by using effect function. Now we don't use effect function to change the value of a signal. Instead, we use effect function to execute some extra logic whenever the value of a signal changes. Let's try to understand that with an example. So in order to use effect function, basically we can use effect function anywhere. We can also use it in a constructor or in ng on init lifecycle hook. So here I will simply create a constructor and there I will use the effect function. Okay, so in here I'm going to call the effect function, and to this effect function we need to pass a callback function. And inside this callback function, I'm simply going to write a console.log statement, and there I will simply say new counter value is, and then I'll use the counter signal. So here I'll say this dot counter. So inside this effect function, we are using this counter signal. So whenever the value of this counter signal will change, this callback function which we are passing to this effect function, that will be called, and it is going to log this message in the console. Let's actually see that. Let's save the changes. Let's go to the web page, and in here let me first open developer console. Let me clear everything, and now when I click on this plus button, you will notice that that message new counter value is 1 has been logged. If I click on this plus button again you will see the message new counter value is 2 that has been logged. If I click on this minus button, the counter value has again changed, and you will see this message new counter value is 1. So every time the value of this counter signal will change, this callback function which we are passing to this effect function, that will be called. Now what will happen if I don't specify any signal inside this effect function? So for example, if I remove this signal from here, in that case, we are not using any signal inside this effect function. Then when this callback function will be called, on which signal change this callback function should be called? Well, since we are not using any signal inside this callback function which we are passing to this effect function, now this callback function will never get called. So if I save the changes, if I go back to the web page, and now when I click on this plus button, you will see that that message is not being logged. That's because now this effect function does not know on which signal change it should be calling this callback function. But if I go ahead and if I specify that counter signal back, in that case, now this callback function will be called every time the value of this counter signal changes. Here, instead of counter signal, if I use message signal, in that case, this callback function will be called every time the value of this message signal changes. Okay, but let me make it as counter signal. So basically the effect function allows you to define a code that depends on a signal, and Angular will automatically re-execute the callback function that we are passing to the effect whenever any signal being used inside that function changes. So we use computed function to compute a value from a signal value, and we use effect function whenever we want to execute some code when the value of a signal changes. And with that, this is all about signals. Now there are more features to be added to Signal in the future, and I will cover those features when it is available. And if you want to see what are the new features that might get added to Signals, let's go to browser, and there let's search for Angular Signal RFCs. And here you will see a GitHub link. Let's just open that. And here you can see the RFCs for Angular Signals. So RFCs basically stands for Request for Comments document. And you can read this document to learn more about signals and their development process. And if we scroll down here, you will see that here we have several RFCs, and one of the RFCs is for signal based components. If I open this RFC, this is a new feature which will get added to signals, but this feature is not available in Angular 16 version. This might get added in the future versions of Angular. And this feature will basically allow us to create signal based components. And to create signal based components, all we will have to do is, here you can see this syntax. So in the component decorator, we will have to specify a signal property, and we will have to set it to true. In that way, we will create a signal based component. So this syntax, it does not work yet, but it is likely to be added in the future. And as I mentioned earlier, the signal feature is still in development and it's not complete yet. There is a bit more to be added. And this is all about signals for now. As mentioned, this feature is in developer preview, so there is not much to cover right now. And this signal feature is not yet final and stable. I'll update this section when we will have more features to cover related to signals. But in the future, signals might give us a nice alternate way of handling change detections. So, as we learned before, signal provides us more advantage over old change detection mechanism in terms of performance, and it gives developers more control over when change should be detected. This is all from this section. If you have any questions, then feel free to ask it. Thank you for listening and have a great day.